In order to find the average velocity over this time interval, we need to substitute both of these times into the function and find out the two heights. So we've got the height at 2 seconds minus the height at 1.9 seconds is how far it went up or how far it dropped over that time interval. And if you subtract the two, we can find out that it took 0.1 seconds in order to do that. So here's the function. If I go to the graph and substitute in a 2, it's going to say that it was at a height of 42 feet. Substitute a 1.9, and that's 43.24, so it's actually falling over that 0.1 seconds. And then if we subtract them, so 42 minus 43.24 divided by 0.1, negative 12.4, and it would be in feet per second. So it's dropping at about 12.4 feet per second. Geometrically, if you take a look at the picture, what's going on is it's saying substitute in a 1.9, that was this height, substitute a 2, and that's this height, so it fell. And then if this were a straight line, then the velocity would be 12.4. Of course, it's not exactly a straight line, but that'll be a pretty good estimate. Now let's find the actual velocity at 2 seconds. So this right here is a key statement saying take the derivative. So we can use the form take the limit as x approaches whatever number is being talked about, 2. And then we basically do the same thing over here, except we use x and 2 instead of 2 and 1.9. So it's going to be what's the height at time x minus what's the height at time 2, and then find the length of that time interval, so it's x minus 2. Substituting x in there, of course, we get negative 16x squared plus 50x plus 6. And then when we substituted the 2 in there, that was the 42. And then I can combine like terms, so this will make it negative 36. So we've got the limit as x approaches 2 of a negative 16x squared, a positive 50x, and then what's left is negative 36. Okay. Now, in order to take the limit, we need to substitute in a 2, but that causes division by 0. In order to get rid of that problem, we need to factor this. And one of the factors will be an x minus 2. So factor an x minus 2 times something in order to get this. Well, with the x's, I would need a negative 16x times x is negative 16x squared. And then this would need to be a positive 18 times a negative 2 would be negative 36. But now we need to make sure that that works for this 50x, see if that's right. Well, right here and here, we would have positive 32x. And from the outside one times the outside one, that would be positive 18x, which sure enough works. That's positive 50x. Great. So now we can cancel these factors, and now there's no more division by 0. Substitute the 2, so it's going to be negative 16 times 2 plus an 18. And so the final answer seems to be negative 14 feet per second. So our estimate over here of negative 12.4 was okay, but to be more accurate, it's actually the instantaneous velocity, negative 14 feet per second.